Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 21 from the October-November 2022 paper 2 variant 3 from the Cambridge IGCSE 0580 syllabus. And this is a very important question for a few reasons. It says the diagram shows the positions of three ships A, B, and C. AC is 17.6 kilometers, BC is 12.8 kilometers, and BAC is 25 degrees. The bearing of C from B is 112 degrees. The bearing of C from B is 112 degrees, and ABC is obtuse. Now, very, very important for us to read the question carefully. It says angle ABC is obtuse. Okay, and that's a very, very important point here. Okay, so this angle here is an obtuse angle. Obtuse means it is more than 90 and less than 180. Okay, so it says calculate the bearing of B from A. So when we talk about bearings, the bearing of B from A. Now, bearings are always measured from the north line, and they're measured in the clockwise direction. Okay, and they're written with three figures. So the bearing of B from A, it says from A. So it's like you're at A, and you have to draw the north line, therefore at A, where you are. So at A, I'm going to draw a line which is going to be north. Okay, the north line. Okay, it's parallel to the north line here, of course. Right? So I'm going to draw this line. So the bearing of B from A would be the angle over here. From the north line, going clockwise, the same way that the clock turns, until you are facing B. So you're at A, you face north, you turn clockwise until you're facing B. The angle you've turned through is the bearing of B from A. Okay, so for us to find this angle here, what we need to do is we need to understand that we should really find this angle over here. This angle over here, if I find this angle here, this will be, with this supplementary, they'll add up to 180 degrees because we'll have, these two angles are all interior angles. Okay, they make an angle, the sum is 180. They make like a U or a C shape. So this angle here and this angle here, they are basically supplementary. So if I call, for example, this angle X, then what we need is going to be, this angle is going to be 180 minus X. So how can I find X? Well, if I find the angle over here. So let me call this angle Y. This is the angle I'm trying to find now. If I find this angle, I can then find this angle because this makes one complete circle. So I'll have 112 plus this angle. Subtracted from 360 will give me this angle. Once I've got that angle, I can find my bearing that I'm looking for. So the key now is to find this angle Y, which is the angle ABC, which is, we know this is obtuse. So let's think about how we can find this. We've got this triangle. It's not a right angle triangle. And it seems like we can use the sine rule because we have pairs of opposites. Because I have this side and this angle, and this side and this angle I want to find. Only one of the things we don't know. And we know the sine rule is such that the sine of an angle over the length of the side opposite it is equal to the sine of another angle in the same triangle over the length of the side opposite it. That must be the sine of that angle. So in this case, we can apply this to this particular question by writing down that the sine of Y, which is what we're trying to find, over the length opposite it, which is 17.6 kilometers, is equal to the sine of 25 divided by the length opposite it, which is 12.8. So from here, we can say the sine of Y is equal to, if you cross multiply, 17.6 times sine 25, like multiplying both sides by 17.6 over 12.8. So now we can put this in our calculator and find what Y is. Okay, so Y is going to be the inverse sine of all of this. I'll just write it like that for now to make it clear. You don't have to write it as a decimal. You can leave it like that. Okay, and then you can write your answer down. So we'll take the calculator. We make sure that we are in degree mode. Now the calculator right now is in radian mode. So I'm going to make sure that we're in degree mode. Very important. So number one is degree mode. So now we're in degree mode. So we say inverse sine of 17.6 times sine of 25 over 12.8. Over 12.8. Okay, and that gives us the angle. Now, what we'll be surprised with is the angle we get here, as we can see from the calculator, is 35.527. 35.527, it goes on like that. Now, the issue with this is, this says obtuse, and this is acute. Okay, now that's where you got to be very careful with the sine rule. And when you're using the sine rule, it's possible that you're looking for an obtuse angle, but the sine rule will always give you an acute angle. It will always give you an acute angle. But you want to find the obtuse angle which shares the same sine ratio as it. And the reason why that happens is because of the sine curve. It looks like this. Between 0 and 180, it looks like this. It continues on, as we know. But for triangles, we're concerned between 0 and 180. This is 90. So basically, what we found that there is a angle, which is this angle here, 35.527, which gives you a particular sine ratio. Now there's another angle, which is over here, which gives you the same sine ratio, okay, but it is an obtuse angle. Okay, the calculator will only ever give you the acute angle. It's called the principal solution. To find the other solution, you use the symmetry of the sine curve. The distance of this angle 35 from 0 is, of course, 35.527. And the distance between 180 and this, the other angle, well, it's that same distance less than 180. So the actual y that we're looking for is going to be 180 minus 35.527. So I'm going to call this y dash because it's not actually our y at this point. From there, it's okay, but I'm going to call this y dash. The actual y we're looking for is going to be this one. So we're going to take our answer, and we're going to do 180 minus the answer. 180 minus our answer, keep it in exact form. That gives you 144.472. 144.472. Don't round anything yet. Leave it like to more high degree of action than you need. And then it says, calculate the, so now we've got this angle here. So this is now 0.472. Sorry, that's this angle here. Okay, so the angle we need, x, is going to be 360 minus the sum of these two. So the angle that we've written down as x there is 360 minus 144.472 plus the angle that was given there, which is 112. 144. Be careful. Don't write things down wrong. 144 plus 112. Okay. All right. So that will give you the angle x. So we're going to take this, we're going to add to it 112. And that we're going to do 360 minus that. And that gives us 103.527. So x equals 103.527. So therefore we can say our bearing is equal to, so our angle is going to be 180, the bearing that we're looking for, the bearing of B from A is going to be 180 minus this angle. So we'll take our answer here and we do 180, take away this answer, and that gives us 76.472. Okay, in fact, I won't call this the bearing for now because it should be 3 figures. So I'll call this angle that, let's call this angle Z for now. We've got X, Y, and Z. So angle Z is equal to this. Therefore, we can say the bearing of A from B, sorry, B from A, way around. B from A is going to be 076 degrees. So bearings, you can write them, you should write them as three figures. And that's why normally you would round them to the nearest whole number. If you wrote them to one decimal place, because angles can be rounded to one decimal place, that's acceptable as well, as the mark scheme shows. But really, bearings should be written to the nearest degree, okay, three figures. And if they are a 1-digit or 2-digit answer, you put a 0 before those digits. So if it's 76 degrees like this, you put a 0 before in the beginning, so it reads as 076 degrees. So there's the answer to this question. So the important points here is this fact that the sine, the sine rule always will give you an acute angle, but sometimes they're looking for the obtuse angle, which shares the same sine ratio. So if you see this, it says obtuse. Sometimes in the questions they have it in bold type to bring your attention to it, but don't get fooled by that. Be careful, read the question carefully. Read every word of the question, because some people, they'll just say calculate the bearing of B from A. They'll see all the numbers written there and they won't pay attention to what's written here, and they will miss the fact that it says obtuse, and then they will use this answer here of 35 and they'll call this angle 35, and they will have 112 plus 35, and the whole of their bearing will be completely incorrect. The answer will be completely wrong. So please make sure that you read the question carefully and you pay attention and you realize this thing about the sine rule. The sine rule will always give you an acute angle. If the question asks you for an obtuse angle, you take that angle you found and you do 180 minus that angle, and this is the reasoning behind it. So I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of trigonometry, sine rule and cosine rule can be found in the playlist over here. Questions dealing with bearings in a separate playlist will be over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.